Hi, Anna.
Hi.
How are you tonight?
Can you hear me?
Yes, I can.
Good, how are you?
I'm good. So do you have stuff you can verbalize tonight, or do you need to send me something?
No, I have things I can verbalize.
Okay.
Um, let's see. Okay, so I have a bunch of questions on on our Unit 3 study guide.
Okay.
So, verbalize those. So the first one is a to the negative third, and then b squared over a to the fifth power.
All right. Whenever you have a negative exponent, if you like, the very first thing you can do is take it to the other side of the fraction bar, regardless of which side it's on to begin with. In other
Okay.
words, I'm going to leave my b squared up there, and I'm going to take the a cubed and put it down there with a positive exponent. And had it been on the other side of the fraction bar, I could have done exactly the same thing, moved it to the numerator and changed the exponent, the sign on the exponent. Okay? Now the problem actually becomes a little easier because you don't have to deal with negative numbers or subtraction. So what's my answer? B squared over what?
A to the negative. Oh, wait, not to the negative. Would it just be a to the second, or a squared?
No, we're multiplying. Even though it looks like we're dividing, is all we're doing at the moment is simplifying that part right there. And that's multiplication.
Okay.
So it's a to the eighth. We
Okay.
add exponents. Okay? Now, not to confuse you, but there's lots of ways to do this problem. That's one way. To me, that's the easiest. Makes the most sense, doesn't involve subtraction. There is another way that produces the same answer, and that is treating this as division. So, in other words, if this is my first step, what's the answer to that? Subtract exponent, because I do have division going on here now.
Okay.
So that's a to the minus eighth, right? When I'm doing division, I subtract the exponents. And that's the same as 1 over a to the positive eighth. They always want you to give your answers with positive exponents, not negative ones. So even though this might be equal to b squared times a to the negative eighth, I'm never going to give that as an answer. I'm always going to put the a on the other side of the fraction bar and change that negative 8 to a positive 8. And like I said, it works both ways. If I had a to the minus fifth, I can immediately take that and put it in the numerator so that it's a to the positive.
Okay.
Okay, as long as there's nothing else going on. Now, if I had that being squared, that's a different story. Then I would want to do the squaring first before I fiddled with moving it. I wouldn't want to move it if the whole thing was being squared.
Okay.
You can't do that. All right, what else you got?
So this one says evaluate f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8 when x equals 3.
Okay. What that means is f of 3. In other words, when I write a function and I put something inside the parentheses other than the x, it means whatever I write inside that parentheses, I'm going to substitute wherever I see x. So the way I advise doing these is very carefully and one step at a time. If you try to do too many steps at a time, it's real easy to make a mistake. Okay? So I'm going to write it exactly like this. One step at a time. Now simplify. What's that become?
So do I multiply 3 to the fourth?
Well, you have to do the exponential part first. In other words, remember PEMDAS, right? Parentheses and exponentials you have to do first. Besides that, the 4 is not acting on the 2. So I can't do anything with the 2 and the 3 because the 3 is being taken to the 4th power and the 2 is just multiplying whatever that is. So do the exponents first. What's 3 to the 4th power?
81.
Okay, and then 2 times 81 is 162. What's 3 cubed?
27.
And then 5 times 27 is 135. And then minus 12 plus 8. That's 27 minus 12 is 15 plus 8. If I did my arithmetic right, that's our answer. And you sure there was no x squared term? This was the right polynomial? Because it is missing an x squared term. I didn't know if that was intentional or you just left off the square. But the key thing is understanding that terminology right there. Or if I were to say, what is f of x minus 1? Then I substitute x minus 1 wherever I see an x. So, you know, I would start out by 2 times x minus 1 to the 4th and go from there. But this notation becomes more and more important the higher up you go in math. Really important in calculus and precalculus. Okay, what else you got?
It says factor and solve, and this one says g of x equals x cubed plus 5x squared minus 9x minus 45.
Okay. This is one of those rare cubics that you can actually factor in a normal way by grouping. Okay? I would say of all the cubic functions out there, you'd be lucky to find 1% of them that can be grouped. And what you need for grouping to work is for the ratio of the two coefficients, 1 to 5, be exactly the same as the ratio of the last two numbers. Minus 9 over minus 45, that's also 1 to 5.
Okay.
You see where I got the 1 to 5? There's a 1 in front of the x cubed?
Yeah.
Okay.
Does it always have to be 1 and 5?
No, it can be any. In other words, if I made that 2 and made that 18, now it's the same ratio. It's 2/5, same as 18 45ths.
Yeah, it always has to be equivalent to 1.
The ratio has to be the same. That's the key.
Okay.
Okay. That was a 9, right? Now, it's still a little bit of a difficult problem when there's a minus sign in front of that 9. I'll show you what happens. The typical way you group is you group the first two terms together and you group the last two terms together and you put them in parentheses. Okay? So the key is not to change the function. Whenever you're manipulating a function, you do not want to change it. So what goes in those two that second set of parentheses?
Would it be 9x minus 45?
Well, is that the same as the original?
Yeah.
No, it isn't. This negative sign applies to both terms in there.
Oh.
So
you have to make that a positive.
Got to make it a positive. In other words, you got to be very, very careful whenever subtraction is taking place. If that was a plus sign, then I can just add the two sets of parentheses and I don't need to worry about it. But when subtraction is taking place, just what I tell every single person that I work with is when you're going from one step to the other, always be checking. Every time you make a change to the function, whether it's putting parentheses around something or whatever, make sure you haven't changed it. Because it is so easy to make the mistake that you made. I would say 95% of my students make that mistake. Okay, when they add the parentheses, they don't change the sign of this number here. All right, now that we've got them both in parentheses, I'm going to factor out the greatest common factor from each. What's the greatest common factor from the left two terms?
5. Oh, no. It'd be 1.
Include the variable. The variable is the most...
1x? Oh, yeah, 1x.
It's x squared. That's the greatest common factor. Remember what greatest common factor means. It means the greatest entity that will divide evenly into both of these terms. Notice that 5 doesn't work. I cannot divide this first term by 5. So the only thing I can divide both terms by is x or x squared. And greatest common factor, I'm going to do x squared. What's left after I factor out the x squared?
X and 5, or x plus 5.
Okay, now factor out the greatest common factor from the second two terms.
9, or just 9.
And what's left?
X plus 45.
X plus 5 again. If that is not the same as that, you either have made a mistake or it can't be solved by grouping. In other words, one feature of grouping is that when you factor out your greatest common factor, you're left with a binomial that matches this binomial over here. Now, I can actually factor out that binomial, which is not something you're used to doing. I'm not sure you've ever done it. This might be the very first place where you actually factor out a binomial. And what that means is I'm going to divide that term by x plus 5, and I'm going to divide that term by x plus 5. So when I do that, what am I left with?
Would it just be x?
Back up a step. Here's what I'm doing. I'm dividing that term by x plus 5, and I'm dividing that term by x plus 5. That's what it means to factor out a greatest common factor. So when I do that, what's left here?
Well, negative 9, right?
On the left, what I've circled, what's left there?
X squared.
Okay. And what's left over here?
Negative 9.
Okay. That's what you get. In other words, if I multiply these two things back together again, I'll get my original cubic. Now, I'm not done because I can factor the x squared minus 9. Notice that's the difference of perfect squares. What's it factor into?
Wait, so what am I looking for when I factor that?
Factoring the difference of perfect squares. Factors into x minus 3 times x plus 3.
Oh, right, because those both end up
That's a
being
really
nothing.
common one that you're going to run into a lot, difference of perfect squares. You want to make sure you recognize it when you see it, okay? Because it's really easy to factor. It's one of the easiest quadratics to factor. You just take the square root of this term minus the square root of this term and then times its conjugate, okay? So this is equal to the original function. And they said solve it. Well, they didn't really mean solve it. They meant find the zeros. Because there's no solving this.
Okay.
This is a function.
Right.
I could graph this function, but unless you set it equal to something, you can't solve it. Well, the only thing that I can do is set it equal to 0, and that's going to find the zeros. In other words, this function might look something like that, okay? The reason I set it equal to 0 is I'm trying to find that point, and that point, and at all three of those points, my g of x is equal to 0. So that's why you set these things equal to 0 when you're trying to solve for the x-intercepts, or what they call the zeros. You know, the x-intercepts are called zeros of a function. So when they said solve it, that's what they meant. They couldn't have meant anything else, I don't think. But now, how do I solve this? In other words, I've set these three linear factors equal to 0. What does that mean x is?
Well, x has to be 0.
No?
Right?
The fundamental law of algebra says that if you multiply any number of things together and the result is 0, then one of those things has to be 0. You cannot multiply three numbers together and have the answer be 0 unless one of those numbers is 0. So the way you solve these, you set that equal to 0 and solve. You set that equal to 0 and solve, and you set that equal to 0 and solve. So I end up with three solutions. What are
they? So
I set x plus 5 equal to 0. Solve that for x.
X equals 5.
No. X plus 5. Set it up as an algebraic equation, just like that.
Okay.
And solve for x.
Oh, x equals negative 5.
Okay. And then do the middle term.
And then x equals...
I didn't hear.
X equals 3. And then x equals negative 3.
Okay. And those are the three zeros of that function. They want you to do anything else with it?
Nope.
Okay. They will not give you haven't had the rational factor theorem yet, have you? The P over Q?
No.
Okay. That means they will not give you a cubic equation that has a constant unless it can be solved by grouping. That's the only thing they've taught you.
Okay.
So you'll never get that question where it's minus 44 because that can't be solved by grouping. In fact, the way you solve the typical cubic is if you cannot take a greatest common factor out, and I can't for either one, whether it's 45 or 44, I cannot take a greatest common factor out, and factoring it is a 20-minute problem, much harder than this. You'll learn that when you take precalc next year, I suppose. You'll get into how to factor cubics. But the first type of cubic that they have you work with is always going to be solvable by grouping. Let me give you one and see if you can tell me whether you can solve it by grouping or not.
Well, no, because that's not equal to 1/5.
No, it doesn't have to be equal to 1/5. That was only that problem. What has to be equal is the ratio of this coefficient divided by this coefficient has to be the same as the ratio of this coefficient divided by that coefficient. So 2 divided by minus 4, is that the same as 8 divided by 16?
Yes.
No, it isn't. This is negative. That's positive.
That's a negative.
They're both 1/2, but this is negative 1/2. So no, you can't use grouping. It's got to be exactly the same. Turn that into a negative 16, and now it is. Now I got 2 divided by minus 4 is equal to 8 divided by minus 16. They're both equal to minus 1/2. Therefore, I can solve it by grouping, but it has to fit it perfectly. And if you solve it by grouping and you find out that you have one of those is an x minus 5 and the other is an x plus 5, you've made a mistake, that's all. Go back and make sure your signs are right. Because the next step after you've grouped it and factored out the greatest common factor is always to factor out that binomial term. So it has to be the same. All right, what else you got?
The question is, write the polynomial function of the least degree that has rational coefficients and leading coefficient of 1 and the given zeros.
Okay, what are the zeros?
-1, 2, and 4.
What does that make my 3 linear factors?
X equals 1.
No, the linear factor would be x minus some number, or x plus some number.
Oh, okay, so would it be x minus 1?
You got to do the reverse of what we just did. In other words, what we just had was 3 linear factors, and you had to find the zeros, right?
Oh, so it'd be x plus 1.
So it's the opposite. You're just doing it in reverse. So, correct?
Okay.
X plus 1. What's the next linear factor?
X minus 2.
And
X minus 4.
okay. Now you have to multiply those 3 linear factors together, and you'll end up with a cubic, a polynomial. And it will have a coefficient of 1 in the highest degree, but we'll talk about that in a second. First of all, let's multiply these 3 things together. The way I always do it is to multiply the last 2 first. And you can multiply the first 2 first. It doesn't really matter. I'll show you why I like doing it the other way, but you can do it in any order you want. In other words, you can multiply the first 2 terms and then take that and multiply it by the third term, or you can multiply the second and third terms together and then multiply that by the first term. Multiply the second and third, and you'll see why I like it a little better. FOIL those together, or multiply them.
Okay. So x squared minus 4x minus 2x plus 8.
And combine the 2 middle terms.
So it'd be x squared minus 6x plus 8.
Now I'm going to multiply that by the other term. And the reason I wanted to do it this way is because, to me, conceptually, it's easier to multiply the binomial times the trinomial than the other way around.
Yeah, that makes sense.
And I multiplied these two terms together first. I'd have my trinomial on the left, my binomial would be on the right, and that's a little harder to see. When you're multiplying these together now, is all you have to do is make sure you multiply every term by every term and use some sort of order so that you make sure you do it the same way every time and that you don't miss one. By that, you don't want to do that times that, and then this times that, and then this times the 8, and then the x times the, I forgot what I did, okay? So don't just be random about your multiplication. Do it in a consistent, steady order. And what I do is always start with the term on the far left, multiply it by all three terms, go back to the next term, multiply it by all three terms, combine everything. So what do you get?
Well, okay, so that's what I have a question about, is multiplying the binomial times the trinomial. Do I multiply every variable times...
E-T-E-T. Instead of FOIL, they should teach this. Because FOIL only works when you're multiplying a binomial by a binomial. Whenever you have anything larger, like we do here, where we have a trinomial, then you want to use ET, which means every term by every term. That's what it means. Okay? So, what we want to do, I'll draw it. When we want to multiply that by that, and we want to multiply that by that, and we want to multiply that by that, then we want to multiply the 1 by that, and then we want to multiply the 1 by that, and then we want to multiply the 1 by that. That's what ET means. And you want to do it in that kind of pattern every time. Like I said, don't jump around haphazardly. Take your first variable, finish it, and then do your second variable, finish it, and then if there's a third variable, if you're multiplying a trinomial by a trinomial, same thing. So what do we get now?
Okay. So it'd be 2x squared.
X times x squared. X times x squared, same base, different exponents. What do?
You add them?
So it's x cubed.
Okay.
Remember, you can't add them together. You can't add x to x squared. You can multiply them, but you can't add them. They're not the same. They're not like terms. I cannot do that. In other words, x plus x squared is x plus x squared. But I can multiply them, and I can divide them, because I've got the same base, just different exponents. So you just have to know how to treat the exponents. Okay, keep going.
And then it'll be negative 4x squared.
Where do you get 4?
I mean, sorry, or negative 6x squared.
Okay.
And then plus 8x.
Keep going.
1x squared.
Plus, gotta have the plus sign. You can't infer it. If I just wrote x squared, it would have no meaning.
Okay. And then minus 3x.
6x?
It'll be minus, it'll actually be minus 5x.
Well, let's not combine them yet. All we're doing is we're multiplying plus 1 times minus 6x. That's minus 6x.
Okay.
Do these things one step at a time. Never try to combine two steps in one in this process. We'll get around
Okay.
to simplifying this. But let's make sure we get every single term right. What's the last term?
Plus 8.
Okay. Now, whenever you do this, you're only going to have one of those on the left side, and you're only going to have one of those. So the terms that need combining are the middle terms. So how many
Right.
total x squareds do we have?
We'll have negative 5x squared.
Okay. And how many x's do we have?
2.
Plus 2x plus 8. So there is our polynomial. And it satisfies their conditions that it has these 3 zeros, and it also satisfies their condition that it have a leading coefficient of 1. What if they'd have said it had to have a leading coefficient of 2? What would my polynomial be?
I don't know.
Well, what I would have to do is multiply the whole thing by 2 in order to give that lead coefficient. That's what I would do. So that would become that minus 10x squared plus 4x plus 16. Now, what might not be apparent to you is that this polynomial has the same zeros.
Yeah, okay.
Okay? In other words, this function 1 and this function 2 are different functions. They're not the same. They wouldn't graph the same. The only thing that's the same about them is they would have the same zeros. In other words, they would cross the x-axis in the same place. Maybe the top function would look like this, and this lower one down here would be a vertical stretch of this one, but it's going to go through the same zeros. It just might look like this instead. Okay? So once you come to the basic polynomial, changing its lead coefficient or its y-intercept, just have to multiply the whole thing by a constant number usually. And probably when they give you these problems, they're always going to say having a lead coefficient of 1. Unless you have some.
Okay, yeah.
Do you have any on your review material that have another condition other than that? Like a particular y-intercept or, all right. All right.
No, but they give us different zeros. Like B for that question is to write the polynomial function of least degree, and the zeros are 4 square root 5.
Okay. We're at the end of our time, but I can certainly help you with that. That's what you meant?
Yeah.
What are the linear?
Or no, like 1 0 and another one was square root 5.
Oh, so there's 4 zeros?
No, there's just 2.
Cut out every other word. You're missing you. I'm not hearing everything you're saying. What are the zeros?
4, and then another 0 is square root 5.
That's it? Just 2 zeros?
Yeah.
Okay, so what are my 2 linear factors?
What is, one will be x minus 4, and one will be x plus or minus 5.
Minus root 5.
Okay.
So multiply those 2 numbers together using ET, and you'll end up with a quadratic, which will satisfy the requirement that it have those zeros and that it is the lowest leading coefficient that you can get.
Okay.
Okay? So it doesn't matter how many zeros they give you. If they gave you 5 zeros, you'd have 5 linear factors. You've had imaginary numbers or not?
Yes.
Okay, the one thing to look out for, let me just tell you this before I let you go here, is if they give you an imaginary zero, let's say they tell you that 3 plus I is 1 0. You automatically, the complex zeros always come in pairs. If this is 1 0, then this is another, automatically. So they'll frequently just give you one of the imaginary zeros and leave it up to you to figure out there has to be another one. Okay? And the linear factors, if they gave me these two, would be x minus 3 plus I times x minus 3 minus I. In other words, you handle complex numbers the same exact way. Now, of course, you have a trinomial times a trinomial, but that's okay. You know how to do that.
Yeah.
Every term by every term. This will end up, if you multiply that back together, it'll end up as a quadratic that produces only imaginary solutions.
Okay.
Anna, I'm going to let you go.
All right.
Be forewarned that the next 2 weeks I tend to get booked really solid. So if you know you got finals coming up in 10 days and you might need an extra session or two, make sure you schedule it early. By that, I mean, if you wait a week, it won't be available. Not unless it's on a Friday, Saturday,
Okay, yeah,
or a Sunday. Okay?
Okay.
Okay? All right. Talk to you
All right.
at least next Wednesday.
Okay.
All right. Bye-bye.